In this module, you will learn about angles and the units for their measurement. Consider two rays OA and OB originating from a point O. If one ray is fixed and the other is rotated about it, an angle is formed. An angle can be mathematically defined as the measure of rotation of a given ray about its initial point. Let ray OA be rotated in the anti-clockwise direction to meet ray OB. Ray OA is called the initial side of the angle, and the destination ray OB is called the terminal side of the angle. If the direction of rotation is counterclockwise, then the magnitude of the angle is conveniently taken as positive. Now, let ray OA be rotated in the clockwise direction to meet ray OB as shown. In this case, the magnitude of the angle is negative. The point of origin of the two rays of an angle is called the vertex. When the initial ray OA takes one complete revolution and comes back to its original position, then it makes an angle of 360 degrees. When rays OA and OB are in the opposite directions, an angle of 180 degrees is formed. The two units used most commonly for the measurement of an angle are degree measure and radian measure. First, let us discuss the degree measure. An angle is of measure 1 degree if the rotation from the initial side to the terminal side is 1/360th of a revolution. 1 degree is denoted as shown. A degree is divided into 60 equal parts, and each part is called a minute. That is, 1 degree is equal to 60 minutes. In other words, 1/60th of a degree is equal to 1 minute. A minute is further divided into 60 equal parts, and each part is called a second. That is, 1 minute is equal to 60 seconds, or 1/60th of a minute is equal to 1 second. Using this, 45 degrees and 15 minutes can be written as 45 1 divided by 4 degrees. These figures depict some angles in degree measure. In the first three figures, the direction of rotation being counterclockwise, the measure of the angle is positive. However, in the fourth figure, the direction of rotation is clockwise. Therefore, the measure of the angle is negative. In this case, the terminal side makes an angle of 45 degrees in the clockwise direction. Hence, this angle is of measure -45 degrees. Let's now discuss the radian measure. The angle subtended by an arc at the center of a circle whose length is equal to the radius of the circle is 1 radian. In other words, let theta be the angle subtended by an arc of a circle of radius r. If the length of the arc is also r, then theta is equal to 1 radian. If the radius of the circle and the length of the arc are equal to 1 unit, then theta is equal to 1 radian. Figure 1 here shows the measure of 1 radian, while figure 2 shows the measure of -1 radian. If the length of the arc of a unit circle is 2.5 units, then the angle made by the arc is 2.5 radians. Guess what is the angle subtended by an arc of length L? It is L divided by R radians. This is because in a circle of radius R, an arc of length R subtends an angle of 1 radian. And since equal arcs of a circle subtend equal angles at the center, an arc of length L subtends an angle of L divided by R radians. Hence, in a circle of radius R, if an arc of length L subtends an angle theta radian at the center, then L is equal to R theta. Let's now compare radian measure with degree measure. Consider a unit circle. We know that the circumference of a circle of radius 1 unit is 2 pi. We also know that an arc of length R of a unit circle subtends an angle of R radians at the center. Hence, 1 complete revolution of the initial side subtends an angle of 2 pi radians. Also, 1 complete revolution of the initial side is equal to 360 degrees. It implies that 360 degrees is equal to 2 pi radians, or 180 degrees is equal to pi radian. The table here shows the degree measures and radian measures of some standard angles. On substituting the value of pi as 22 divided by 7, 1 radian is equal to 57 degrees and 16 minutes approximately, and 1 degree is equal to 0.01746 radians approximately. So we can convert degree measure to radian measure or vice versa using the formulae shown. There is also an alternate formula to convert degree measure to radian measure or vice versa. If D represents the degrees and R represents the radians, then D divided by 90 is equal to R divided by pi upon 2. Let's take one example to convert degree measure into radian measure. Express 120 degrees in radian measure. We have D divided by 90 is equal to R divided by pi upon 2. Substituting the value of D and then simplifying, we get R is equal to 2 pi by 3. Alternatively, to convert degrees into radian measure, we multiply the degree by pi upon 180. Observe that in both the cases, we get 2 pi divided by 3 radian. Let's now convert 3 pi divided by 4 radian into degrees. In the formula, substituting the value of R and simplifying, we get D is equal to 135 degrees. Alternatively, to convert radian measure to degree measure, we substitute 180 in place of pi. On simplifying, we get 135 degrees again.